Okay, today I want to talk about the Jupyter ecosystem. And the Jupyter ecosystem is relatively complex to understand. First of all, Jupyter is a web application. It was always meant to be a web application, but there is also one desktop application now available of Jupyter Lab. Anyway, let's start with Jupyter. So the Jupyter project is basically a relatively simple web application. Sorry, not the Jupyter project, the Jupyter Notebooks. And it's very loved by a lot of users because it's so simple. So you can create notebooks and execute them, and that's basically it. So it has the notion of a kernel where your actual code is being executed. So the front end runs on your browser. It's written in TypeScript, and there is a protocol which then talks from your browser to the Jupyter server, and the Jupyter server instantiates a kernel, and each notebook is then tied to this kernel, and inside this kernel, interpreter is basically executing the contents of your code cells. So Jupyter Notebook got a bigger brother, which is called Jupyter Lab. And Jupyter Lab is a full-fledged IDE, which supports Jupyter Notebooks, but also ordinary code files in Python, R, and you name it. And it again talks to the Jupyter server. And then the Jupyter server is responsible again for creating kernel processes, and in that kernel also the interpreters for Python, R, and whatever are running. So that's basically the core ecosystem, but then there are different other products which are quite interesting and you might hear here and there. So the next thing is Jupyter Hub. And Jupyter Hub is basically a way to spawn remote kernels in a Kubernetes environment. So what you get is you get a URL, and this URL brings you to Jupyter Hub. And in Jupyter Hub, you will be presented the user interface. And in that user interface, you can decide what container image your Jupyter Lab should be based on, and also what resources it has applied to it. For example, the number of CPU cores, main memory, and the potential GPU. And then you can basically start it. So you will be then forwarded to a new URL. That new URL is actually then showing you Jupyter Lab, and the kernel and everything is then self-contained and living in a pod on Kubernetes. So if you hit the URL immediately afterwards, you will be forwarded to that existing instance, but then there's a timeout and eventually the pod gets destroyed. And when you then hit the URL again, then you can recreate a Jupyter Lab for you. In case you want to destroy an existing Jupyter Lab pod, there is a menu item in Jupyter Lab which actually allows you to do that. So when you hit that, it gets destroyed, and then when you hit the URL again, you are brought directly to the Jupyter Hub web interface. The downside of this is that the actual kernels are still running all in the same pod on Kubernetes. So you are basically bound to the assigned CPUs, main memory, and GPUs when you have instantiated this Jupyter Lab from Jupyter Hub. So another way of actually running kernels outside your pod in other pods in Kubernetes is the so-called Kernel Gateway. So the Jupyter Kernel Gateway allows you to cycle up pods which contain kernels, remote kernels, and through a proxy, then those communications between your user interface and the kernels are then passed through. So there is a protocol between the actual web interface and the Jupyter server and the kernels, and that's easily proxyable because it's HTTP based. Okay, I hope this helps. Have fun and see you soon.